This is number 1 on the more linear modeling practice sheet. This is our lesson. This goes with lesson 7 from linear functions. Number 1 says a water tank is being filled by pumps at a constant rate. The volume of water in the tank, V, in gallons, is given by the equation V of t equals 65t plus 280, where t is the time in minutes the pump has been on. So here's what we have. Let's just talk about the function notation first. This is our output. V of t is our output. That's the volume. How much water? And t, our input, is time. Again, t is our input, and volume is our output. So that's how that function notation is working for us on this problem. Part A says, what rate in gallons per minute is the water being pumped into the tank? Well, remember, we're always looking for y equals mx plus b in this unit. So if you look at our equation there, 65t plus 280, that is in y equals mx plus b format. Our variables don't really matter. Our variables just give us labels. So here, V for volume and T for time. But really, it's X and Y. So 65 is our slope, and that's always the rate. So it's 65. And since our problem said the volume was in gallons and time was in minutes, this would be 65 gallons per minute. Part B is asking you for the amount or the gallons of water that were in the tank when the pumps were turned on. Remember, when we're working with these modeling problems, our B value, which here is 280, is always our starting point or our initial. So here we started with 280 gallons of water, and now we're filling from there. So how many gallons of water were in the tank when the pumps were turned on? We started with 280 gallons, and then we're adding 65 gallons per minute. So that's part A and B. Let's look at part C. I'm going to add a slide. Again, our equation for this whole thing, it's on the top of your problem, but I'm going to rewrite it here. So our equation, volume at a given time, is 65 times time plus 280. So for part C, we're asked to find the volume in the tank after 2 hours. And here are times in minutes. So we want time equals 2 hours. And you have to be careful, because I actually made a mistake on this one the first time I did this problem. If we want the time after 2 hours, and our time was in minutes, remember we have 60 minutes per hour. So 60 times 2 gives us 120 minutes. And that's going to be what we put in for time. Again, be really careful there, because I actually did that problem wrong the first time I did it. I used 2, but our t is in minutes. So when we put this into our equation, we're going to do volume at 120 minutes equals 65 times 120 plus 280. And we're going to put that in our calculator. And we get 8,080. And that's gallons. So after 120 minutes, we have 8,080 gallons of water. And if you want to write that as your input-output here, V of 120 equals 8,080 gallons. All right, I'm going to add another slide. And I'm going to keep rewriting that equation. And it's not a bad thing for you to do either whenever as you go from one part of the problem to another. Rewriting the equation just to remind you what you started with. Oops. We need a plus there. So the last part of this problem, part D, says the pumps will turn off when the volume in the tank hits 10,000 gallons. So that's our output, that's our volume. So for part D, instead of plugging in for time, we're going to plug in for volume. So we're going to plug in here, and it's 10,000. So we have 10,000 equals 65T plus 280. You also know that you shouldn't plug in for T here since it asks you to the nearest minute how long does this after how long does this happen. So you know you're going to be solving for T. So we just need to do a little solving here. We want T all by itself. So 65 times T plus 280. We want to do backwards order of operations. So we're going to subtract the 280 first since that's the number that's furthest away from our T. On the right side of our equation, that cancels. On the left side of our equation, we do that subtraction. We get 9,720 equals 65T. And again, that's 65 times T, so we want to divide to undo that. And when you do 9,720 divided by 65, you get about 150. And remember, we're in minutes. That's our time. Make sure you put units there, so you do want to put minutes. And that should make sense. On the last part, on part C, we were at 8,000, just over 8,000 gallons after 120 minutes. So another half an hour, and you get to 10,000 gallons. All right, that wraps up problem 1.